Greetings, students. Today we're going to be covering Chapter 9, Project Scheduling. And pretty much we're going to talk about project scheduling the rest of the semester. Project scheduling techniques lie at the heart of project planning, subsequent monitoring, and control. So we use our schedule throughout the project to see if we need more time, or if we are on time, or if we are lagging. So the unit outcomes are to understand and apply key scheduling terminology, and your book covers even more than I'm going to cover during this lecture. And then we're going to apply the logic used to create activity networks, including predecessor and successor tasks. You have done your WBSs already, your work breakdown structures, but we haven't spent time on the order of operations, the fact that some tasks have to be completed before other tasks can begin, or vice versa. So, project scheduling has been defined by the Project Management Body of Knowledge, the PMBOK, as an output of a schedule model that presents linked activities with planned dates, durations, milestones, and resources. And this comes from page 315 in your textbook. Here is an example of a task list from Project Libra. You're familiar with this. You've done your work breakdown structures. And it shows a reasonable sequence of the predecessors identified by a number. Now, in your text, when you're assigned these Gantt charts and network diagrams coming up, Microsoft Project uses alphabet letters for the predecessors and successors, but Project Libra uses numbers. It numbers the tasks. So you can see here that we're going to be writing a research paper, and we can't research the topic until we have identified the topic. So the predecessor for research topic is number 1. And then we go through the draft and prepare the class presentation. And if you note, we can't complete the final draft until we have written the first draft. So the predecessor there is number 3. The rest of it is just finishing up the paper. And it shows you, though, that these predecessors have to be put there, and you're going to be doing that in your homework assignment. So, Project Libra does this for you. You're not going to have to physically build the network diagram, because if you'll note, when you go to View and Network, it's going to build it for you. And it shows you in red the critical path, which is the longest path through the project or through the task list. A network clearly illustrates the interdependence of all tasks. A network helps master scheduling of resources. If you note in the previous slide, there are places next to predecessors for your resources, and you can identify those here by this button. Identifies the critical activities is another thing that the network diagram does, and identifies and determines when you can expect the project to be completed. Dates on when the task must be started and end keep the overall schedule are identified, and it demonstrates which activities are dependent. So here's some key scheduling terminology. I'm not going to go through every one of the definitions that your book does, but you need to read those and understand them, because we're going to be applying them more in Chapter 10. We know about the scope, we know about scope creep, and how scope can get out of control. And the scope is all the activities that need to be performed. You also know about a work breakdown structure. You've done one, and it graphically shows the total work to be completed. I don't believe we've talked about a work package yet, but it's just a task or activity and is a deliverable at the lowest level of the work breakdown structure. So it's really nothing new, just a new term. Then the project network diagram. We've looked at that, and you've seen the critical path and the fact that it's a schematic display of the logical relationship of project activities. The path is simply the sequence of activities, and an event is a point where an activity is either started or completed. Then we have the node, which is one of the defining points of a network. It's a junction point joined to some or all of the others by the path. Then we're adding predecessors and successors in the critical path to our knowledge of work breakdown structures. Predecessors are those things that must happen before the next thing can happen. And we showed you that, where you've got to do the first draft before you can write the final paper. And then successors are the things that are completed after. And as we said, the critical path is the longest path to completion, shown in red in Project Libra. So how do we figure out how long things are going to take us? Well, in writing a research paper, you probably know and have had experience in how long it's going to take you to do things. To come up with a topic, you may need to read a couple of things. You may need to go through some journals. You may have to dig around in some old classes. And so that may take you 2 or 3 days. And that comes from your own experience. You know how long it's going to take you to do the research. You figured out how long it's going to take you to write a first draft, and so forth. That's the same thing that happens with projects. We bring in experienced folks who have worked on projects, maybe similar or maybe dissimilar projects, and they have the experience to figure out how long things are going to take. Then we have expert opinion. We can bring in the manufacturing people, the engineers, and get their expert opinion on how long a task is going to take. And then we can do it with mathematical derivation. So there are mathematical formulas that we won't be using, but that are available to figure out the estimation of a task. So we've talked about key scheduling terminology. We'll apply more of that in Chapter 10. And we're applying the logic used to create activity networks, including predecessor and successor tasks. And that's what you'll be doing in your homework this week. Have a good one.